Okay folks, hold on tight. Scientists have discovered a gigantic anomaly beneath the Bermuda Triangle, something that exists nowhere else on Earth. Today, we'll take a look at what exactly lies beneath Bermuda, and whether this solves the mystery behind the Bermuda Triangle,
and why this discovery is important for understanding the secrets of our planet. So make sure to stay tuned until the end. A warm welcome, everyone.
Everyone knows about the Bermuda Triangle, this mysterious part of the Atlantic Ocean where ships and planes supposedly disappear without a trace. It fascinated me immensely as a child. Write to me and tell me how it was for you, and as a child, I somehow thought that the Bermuda Triangle would play a more important role in my life.
Like quicksand or monster trucks. But alright. By the way, if you always want to be instantly informed about such exciting discoveries, then go ahead and subscribe to the channel right now. Subscribing doesn't cost anything. You'll never miss a video again, and you really help me out a lot. And if you've already subscribed, giving this video a thumbs up helps it a lot. Let's try to hit 5,000 likes. Thank you so much, everyone. So what exactly did the scientists discover?
A team of researchers has used seismic waves to detect a gigantic layer of rock beneath Bermuda. This layer is an incredible 20 kilometers thick and lies between the oceanic crust and the Earth's mantle. By comparison, in most other parts of the ocean, such a layer either does not exist at all or is at most half as thick. Dr. William Fraser of the Carnegie Science Institute explains, typically, you would have the bottom of the oceanic crust and then you would expect the mantle to follow, but under Bermuda, there is this other layer that is placed below the crust within the tectonic plate on which Bermuda sits.
So, a tectonic anomaly directly beneath the famous region where ships are said to mysteriously disappear. I think we're onto something here.
So what is this huge layer of rock doing down there? To understand this, we first need to look at what makes Bermuda so special. Bermuda is a geological anomaly. The island is of volcanic origin and sits on a massive bulge in the seabed known as a bathymetric swell. Normally, such bulges occur when a column of hot rock, known as a mantle plume, pushes against the tectonic plate from below, causing it to bulge upward. There is no evidence of such a hot mantle plume beneath Bermuda. The last volcanic eruption in Bermuda was over 30 million years ago. According to classical theory, this bulge should have collapsed long ago, but that has not happened. Bermuda still rises about 500 meters above the surrounding seabed. What is holding the island up there? The answer may lie precisely in this mysterious 20-kilometer thick layer of rock. Scientists have analyzed data from a seismic station permanently installed in Bermuda. They used records of earthquakes from around the world. When the seismic waves from such earthquakes travel through different rock layers, they produce tiny echoes. By measuring how long these echoes take to reach the station, it is possible to characterize the structures beneath the surface. And that is exactly how the researchers discovered this enormous anomaly. The scientists suspect that this massive layer consists of magma that cooled about 30 to 35 million years ago during Bermuda's last phase of volcanic activity. However, the rock is slightly less dense than the surrounding mantle material. It is precisely this difference in density that could provide the necessary buoyancy to support the bulge from below. This process is also known as underplating. It is as if a huge geological air mattress had been installed under Bermuda, pushing the island upwards. But how much less dense would this layer have to be to support a 500-meter high bulge? The researchers have calculated that, assuming the seabed beneath Bermuda is in long-term equilibrium, i.e. all forces are balanced, the underplating layer would have to be about 50 kilograms per cubic meter lighter than the surrounding mantle. With a layer 20 kilometers thick, that makes a huge difference. This discovery not only explains why Bermuda still rises so high, but also sheds new light on other oceanic bulges around the world. Dr. Fraser says understanding an extreme place like Bermuda is important for understanding places that are less extreme. It gives us a sense of what the more normal processes are that occur on Earth and what the more extreme processes are. Bermuda is therefore something of a geological extreme example where we can study fundamental processes of the Earth's crust particularly well. But how exactly did this underplating layer form? The most likely explanation is that during the volcanically active phase 30 to 35 million years ago, large amounts of magma penetrated the lithosphere. Some of this magma made it to the surface and formed the volcanic island, but another part remained stuck under the oceanic crust, cooled and formed this massive anomaly of magmatic rock. So beneath Bermuda lies a kind of geological cushion that has kept the island afloat for millions of years.
But I can already hear some of you nervously asking, but what about the Bermuda Triangle? I have to shatter some of our childhood fantasies now. Scientifically, the Bermuda Triangle is no longer considered an area of extraordinary danger, but rather a completely normal stretch of sea with heavy traffic.
Most of the supposedly mysterious accidents can be explained by storms, strong currents such as the Gulf Stream, navigation errors, or simply poor documentation. Magnetic anomalies or sudden instrument failures have also never been reliably proven. In short, the Bermuda Triangle is less of a physical mystery and more of an extremely successful pop culture phenomenon. But now we know that the region does indeed exhibit an anomaly, but not a supernatural one, rather a tectonic one.
And that's actually much more exciting, isn't it? Although my 11-year-old self would probably have disagreed and claimed that a ship disappearing into the maelstrom is much more exciting. By the way, the researchers also found out that this underplating layer probably extends beyond the island as well.
They suspect that it could extend up to 50 to 100 kilometers from the center of Bermuda. It is essentially like a giant geological bowl beneath the seabed. However, the exact extent cannot be determined with data from just one seismic station. In the study, the scientists write, "We identify structures associated with a previously unreported 20-kilometer thick layer of rock beneath the oceanic crust. This thick layer beneath the crust was likely introduced when Bermuda was volcanically active 30 to 35 million years ago and could support the bathymetric warming." And there is another exciting aspect. Bermuda is not the only place with thick underplating. Scientists have found similarly thick layers beneath the Galapagos Islands. However, unlike Bermuda, all these other places still have active mantle plumes beneath them. Bermuda could therefore be a unique example of how oceanic warming can be maintained over millions of years even without active volcanism.
So, definitely a mysterious, anomalous place, even without disappearing ships. I'll keep you updated on any further discoveries. So please make sure to subscribe to the channel and give it a thumbs up so we can hit 5,000 likes. And now we're traveling from the Bermuda Triangle into outer space.
A normally reliable NASA Mars satellite has just failed after observing the mysterious interstellar object 3I Atlas. Is this just a coincidence, or is there more to it? In addition, the first X-ray images of 3I Atlas are now available. To see them and learn all about this exciting story, simply click on the video displayed at the top right. As always, there's another exciting video about science and space at the bottom right. Otherwise, I would say see you in the next video. Take care, everyone.